Before we start the experiment for today, it's very important for you to know that in paper 3, there are two types of dilution method that you're required to know, and you can be asked to do the dilution in exam. The first type is called the proportional dilution. Okay, so proportional dilution, in proportional dilution, we use the formula M1V1 equals to M2V2. All right. And then in the proportional dilution, you'll be given a stock solution having a M1 concentration. Okay, then you'll be asked to usually to prepare 4 more concentrations. So the 4 more concentrations that you prepare, they must be evenly spaced in their concentration. Say for example, you're given 1% of, let's say, sucrose solution. Then you're asked to make a proportional dilution so that you can make 4 more concentrations. So therefore, from there, you need to do dilution. So therefore, the concentration that you can prepare is 0.8%. So all must be evenly spaced, 0.6%. Okay. So the difference between each other must be the same, 4% and 0.2%. So this can be the concentrations that you need to do and prepare using the proportional dilution. So it's very easy. M1, okay, is already 1%. Okay, let's say for example V2, they will tell you usually you need to prepare total how much volume of each diluted solution. So say for example you need to prepare 10 cm cube. Okay. So M2 is those concentration that you want to prepare, the diluted solution, because M1 is the stock solution. So M2 is the concentration of diluted solution. So you just plug in the numbers. Let's say, for example, you want to prepare 0.8%. Okay. So times the 10 cm cube. So with that, you should be able to find out what is the V1 that you need. Okay, so you're going to find out what is the V1 that you need. So the V1 here is actually equals to 8 cm cube. So therefore, you're going to take 8 cm cube of your stock solution. And because your final volume is 10 cm cube, so you have to add 2 more cm cube of water to make it up to 10 cm cube. So that's how you do your serial dilution, and you do the calculation for the rest to find out what is the V1 that you need to take, and then make it up to 10 cm cube using distilled water. So that is for proportional dilution. Okay. So now we want to focus on what is serial dilution. Now, serial dilution is a series of dilution whereby every time when you do the dilution, you use back the same dilution factor. So I'm going to use this dilution factor 10 times to illustrate the meaning of serial dilution. Okay. That means to say from your original stock solution, which is say 1% concentration of sucrose. Okay, so this is 1%. You're going to make a series of dilution, and every time you dilute, your dilution factor is 10 times. That means you're going to dilute this 1% by 10 times. Okay, so how do you dilute this 1% by 10 times is you take 1 part of this stock solution, 1 part of it, and you make it up to 10 parts. So you add with 9 ml of water. So in these 10 parts, okay, 1 part is the original solution. So you have already diluted it 10 times. So when you say dilution factor 10 times, you're trying to dilute it 10 times. So how to dilute it 10 times? From original volume, you make it up to 10. So 1 ml of stock and 9 ml of the distilled water. So your original solution will have been diluted by 10 times. So because of that, the concentration of this second solution should be 1/10 of the original. So 1/10 of original means it must be 0.1%. 0.1%. Okay, and then from here, in the second solution, you're going to make your third solution. So the third solution is also a dilution by factor by 10 times. So you take 1 ml from your second solution, transfer to the third test tube, and add with 9 ml of water. So now this solution will be diluted 10 times from the previous one. So from the previous one, if you dilute it by 10 times, the concentration will be 1/10 of the previous one. So 1/10 of 0.1% becomes 0.01%. Okay, so you will do the same for the last two test tube. So take another 1 ml from this solution, add 9 ml of water. So you will dilute it for another 10 times. So concentration becomes 1/10 of this. And do the same for the next one. Take 1 ml from this solution and add 9 ml water. So dilute again by 10 times. So the concentration becomes 1/10. Okay. So if you want to use a formula, this is a formula. That means M2 is the concentration of the diluted solution, is equals to original concentration before dilution times 1 out of the dilution factor, like just now 1/10. If the dilution is 10 times, dilution factor is 10 times, then the concentration of diluted solution is 1 out of 10 of the original concentration. Okay. Or you can also use V1 over V2. So this is how much volume of the concentrated solution. This is the final volume of the diluted solution. Okay, times the original concentration. So this is called the serial dilution. So therefore, you need to know both ways of making dilution in exam. First one is proportional dilution, and second one is the serial dilution. So this is the beaker containing Visking tubing, right? So the Visking tubing will be immersed in distilled water. So you need to take one piece out of it, okay? And then you need to tie one end, to tie a knot at one of the ends, okay? So can someone help me to? Can you please help me to tie a knot as close to the end as possible? This procedure is very important because you want to make sure that the knot will be tight so that the liquid in the Visking tubing, when you add in later on, will you have to make the knot as close to the end here as possible so that you got the body to add a longer body to add in the solution. Okay, so this one is a bit the edge. So maybe you tie the knot near to the edge here, then at least you got more body to fill in the plant extract. Yeah. Okay, thank you. And then step number 2, you need to rub. You see, it's wet, so when you rub, right, it will open up. So when you open up, then you're able to fill in. You're able to fill in the plant extract into the Visking tubing. Okay, so once you fill it in, you need to dip this into the original distilled water solution, which is this one here. So this is already filled in already. So once you fill in with the plant, okay, the plant extract, then you need to dip this Visking tubing into the distilled water again to wash its body, just in case when you fill it in, it spills to the side. So you don't want it to contaminate the water surrounding the Visking tubing. So you have to dip it to clean it. Okay. Then after that, just dip it inside there. Okay. So this is step number 6. So the Visking tubing containing the plant extract is already placed into the boiling tube, and you see that the boiling tube is actually bigger than the test tube. You can see that. Okay, so boiling tube is slightly bigger so that the Visking tubing can go inside. So the next thing you need to do is you need to know how much volume of your distilled water that you need to add in to fill up this boiling tube to the level that is indicated in your practical workbook. All right, so to this level you need to add here. So she's measuring like how much volume is needed. All right, now she's using a syringe, okay, to measure the volume of water that is needed to be added into the whisking, to the boiling tube. Okay, so every time you take it up, you take up 10 ml, right? You're measuring 10 ml, right? Okay, so that's the very good way to do. So roughly you need another 10 ml. Okay, if there's any gas bubble inside, you have to remove the water and suck up the water again. Right. Okay, so is it sufficient already, the level?
Yeah.
Sufficient is above the plant extract level. So are you starting?
Yeah.
So she's starting the timer already. Okay. Okay, now we're going to do the dilution. So you can see that there are 4 specimen tubes here. What is the concentration for the first one, G1?
0.5.
0.5. So that means it's already diluted already from the original solution G, which is this one here, right?
Yeah.
So G1 is already diluted. So now let us look at how the dilution is done for G2. So this is a serial dilution. So you're going to take up 10 cm cube from G1, and then you're going to add 10 cm cube of distilled water to the G2. So that means this solution in G2 is already diluted with a factor of 2. That means in every 2 parts of G2, 1 part comes from G1, 1 part comes from distilled water. So this diluted 2 times. Okay, it's diluted 2 times. So its concentration will be half of G1. Okay, now have you mixed the solution well? Yeah, you can use the syringe to mix the solution first. So you're going to make a dilution for G3. So in the same way, he's going to withdraw 10 cm cube from G2. Make sure there's no bubble, or else the measurement is wrong. I've got a lot of bubble on top there. You have to do it again. You have to push the whole thing out because the bubble is too much on top here. So, okay, push the whole thing out, push the bubble up. Okay, so when you withdraw slowly, and then make sure you don't suck up any gas. Okay. Okay, transfer to here, 10 cm cube, and then he's going to add with a different syringe. This is a different syringe, so no contamination. This W, so add distilled water, 10 cm cube to G3. So which means to say that now G3 solution is diluted by 2 times from G2. 1 part of G3 contain 1 part of G2 and 1 part of distilled water. So G3's concentration will be half of G2 because it's diluted 2 times from G2. Okay, so this is called serial dilution. That means you're going to do a series of dilution whereby every time you dilute, it will be the same dilution factor. So in this case, the dilution factor is 2. So that means every 2 parts of a diluted solution, 1 part comes from the previous concentrated solution. Okay, so now he's going to draw another 10 cm cube from G3, okay, to make the dilution for G4. And then he's going to use another syringe to withdraw 10 cm³ of distilled water. And then there you go. So it's already diluted 2 times. Yeah, diluted 2 times. So the concentration becomes half of G3.
After we finish the distillation and then the middle part is only 10 cm³ and the last one is 20. It's not the same volume at all.
Okay, you see, very interesting, right? So this is after completion of dilution, right? You started off by making a 20 cm³ of each one, right?
Yes.
But after the 20 cm³, you're going to take 10 cm³ and transfer here, right? Then you add another 10 cm³ of distilled water, so it becomes 20 here. Then from here you take 10 and pass it here and add another 10, so 20 here. Then you take 10 again, cm³, transfer here and add another 10 cm³. So at the end of the day, among all the solution that you diluted solution that you prepared, only the last one will still contain 20 cm³. The rest of them you will only remain with 10 cm³, and that is already sufficient because that's the instruction of the practical worksheet. So you are pretty fine. Okay.
Okay. 10 cm³ of 0.5% glucose.
Okay, very good.
And
then your distilled water.
10 cm³ of
Okay, then you do the same thing for the next one as well as for the subsequent one. Right? How to change? Hey, you have to turn this one until the hole is open. Bunsen burner, right? If you light it, you'll see, okay, what's the color like. Now, how come it's like orangey color? Okay, we don't want the orangey color because the orangey color is going to blacken, you see? It's going to blacken the beaker, see? Okay. So, how to change it to blue color? So, you have to check there's an opening here. There's an opening here. You cannot focus. I think because of an aircon blowing, it's going to caught fire. Okay, here, see, okay, good. Just now, cannot, oh, this is a bit hot. So this is supposed to, there's a hole here. See, there's a hole here. So you're supposed to open this one to ensure that the hole is totally exposed so that enough oxygen comes in. That means this one have to push down. Can you try to push it down? Can or not? Because it's too high up. Is there anything blocking it from going down? No. Okay, no, good. So, okay, very good. So now you see that this hole is totally open and exposed already. See? So with that, you try again. Now, why is it still orange color? At least it's not as much as just now, okay? So we need to make sure that this hole here, why can't I see the hole here? Here's the hole. Okay, this hole must be fully exposed. You cannot focus the. Okay, must be fully exposed so that enough oxygen goes in, then mix with the gas, then the fire should be blue color. Okay. See, now it's blue already, right? And then just now the gas is very low, so you open up more, then the gas becomes higher, then your water can boil. Yeah? Okay, so Dharma what going to do? Going to wipe away the carbon. See, just use the water. The carbon is like a pencil, right? Carbon. You can just remove it with wet tissue paper. So thank you so much, Dharma. So now I think your water will boil very fast. Okay. Do you know why is it? There's an adjustment in the Bunsen burner so that you can change the fire from orange to blue and blue to orange.
No.
You don't know, but you know how to adjust already, right? Okay, it's a very important information here. Okay, Now, in the lab, right, when the fire of the Bunsen burner is blue, sometimes you can't see that the fire is there. Alright, but you want it blue color because blue color is the hottest. So when you want to use it to boil something or heat up something, you use the blue color fire. But when you do not need to use the Bunsen burner already, but you still want the fire to be there, and then you want to continue to do some other parts of experiment before you come back, you need to close the hole. You need to close the hole so less oxygen goes in, the fire becomes orangey color. Because orangey color fire can be easily visible. So that will prevent you from burning yourself. Okay, and also prevent you from forgetting that the gas is on. So that's the purpose of why you change from blue to orange when you don't need to use it, but you just want it to be on, so you don't have to light it again. And when you need it again, you turn it back, open up the pore, allow more oxygen to go in, so the blue fire will come back. So that's the purpose of changing from blue to yellow and yellow to blue. Now you're at step number 11 already. Okay. So she's going to add in 2 cm cube of Benedict solution to the 2 cm cube of the G solution, and then she'll start to do the timing, and she needs to observe the tube quickly. The moment it changes color to yellow, already changed already, can see not? Already changed already, hello? You cannot see. Then you have to time. Okay, so you choose your whatever color change it is, and then you take the time, okay? So how long does it take for the first color change to be visible? Is this the most concentrated one? So the most concentrated one should be the fastest, right? Okay. Can you see the top color change, my dear? You can't see the top color change, my dear? Already changed already? Hello, what's your end point? Okay, so now she's recording the timing for the timing to reach the end point for the first solution. Okay, so the timing is 35 seconds as shown in the stopwatch. Okay, now she's going to do the second one. So she's going to transfer the Visking tubing to the Benedict solution 2 cm cube, and then start the stopwatch. Very good. Put it inside there. Make sure that the level of the water bath must be above the level of the mixture. Maybe later on you need to add a little bit more water, okay? So now she's going to look at the color. The moment there's a slight color change, then she will check the timing and record the time taken for color to change into the table. Okay.
Jo, what is the color change you're supposed to look for?
Okay, what is the color change you're supposed to look for? You decide for yourself. Okay, because you know that for Benedict's test, the color, if there's presence of reducing sugar, it will change from blue, and first it got slightly green color. Okay, then after that slowly turn to yellow, then brown, orange, and brick red. Okay, so therefore you choose the color that you want to determine as the end point, and then you check what is the time taken to reach that color. And of course the color must be easily seen, so that for every test you're going to test later on, right, you're able to see what is the time taken for it to change to that color. Okay, so this experiment, right, is just completed. So what you see is that she has read the end point at the same color, but after she transferred the test tube back to the test tube rack, you can see that the reaction will still continue because the solution is still hot. Okay, so therefore continue until what you see, this is the range of color. So this is brick red. So because this one has got the highest concentration of glucose, so you see it's brick red. Okay, and there's a lot of precipitate inside. If you leave it there for some time, it will start to settle down. Okay, then when it settles down, you see that this tube will have got the most precipitate, followed by the second, third, become less and less precipitate at the bottom if you leave it there for some time. So you see the color slightly become different. This is brown. This one is brown here. And this one, it becomes this original color. So it's a range from blue to blue, red, which is brown, until brick red, this orange. Okay? This is a result that she obtained. It's very interesting. You see that, okay, apart from the first two glucose concentration, right, the rest of them are more than 120. All right? So that means the concentration is so low that it cannot be detected within 120 seconds. And this is the solution S. So it looks like, how long already this one?
More than 5 minutes, I think.
This is already more than 5 minutes. That means to say that it's actually more than 120. So you're supposed to match the S solution color or the timing to this one. So it looks like it can be any one of these, right? So she's saying that she wants to change the result. Okay, so no need to change the result if you are following the instruction in the worksheet. Just be confident with your result, because during the exam time, the supervisor will also be conducting the same experiment using the solutions given. So if you follow the instruction, the supervisor also follow the same instruction, you all should be getting the same result. So this result that the supervisor obtained will be sent to the examiner. Examiner will use it to mark your answer. So don't change your answer if you're very confident that you have followed the instruction to carry out the experiment. Okay, so just be confident with that. Yeah.